Hi everyone, welcome to our MATLAB class. In this short lesson, we are going to explore two ways to create evenly spaced vectors in MATLAB: the colon operator and the linspace function. By the end of this lesson, you should be able to create evenly spaced vectors using both methods and decide which one to use depending on what you need to control, the step size or the number of points. Let's start with a simple example. Suppose we want to represent a sequence of distance values 0, 10, 20, 30, 40, and 50. One way to store these values in MATLAB is by creating a vector. Well, let's take a look. In MATLAB, we can store a sequence of values in a vector. Suppose I want a vector containing the values 0, 10, 20, 30, 40, and 50. Here, I've created a row vector containing 6 values. This works, but notice that these values follow a regular pattern. They increase by 10 each time. Instead of entering every value individually, MATLAB provides us with more efficient ways to create evenly spaced vectors. One of those ways is the colon operator. The start value tells MATLAB where our sequence begins. The step tells MATLAB how much to increase from one value to the next, and the end value defines the upper limit of our sequence. In this example, we want to represent distance values. So we create a sequence that starts at 0, increases by 10 each time, and continues up to an upper limit of 50. Let's see how this works in MATLAB. To create the same vector we just created manually, I can start at 0, increase by 10, and continue up to 50. And we can get the same values without having to enter each one individually. You can pause the video here and try changing the values in the colon operator. What happens if you change the step size from 10 to 5? And what happens if the end value cannot be reached exactly using the chosen step size? Another option is MATLAB's built-in linspace function. Linspace also creates evenly spaced values, but instead of specifying the step size, we specify how many points we want. The function takes a start value, an end value, and the number of points. In this example, we start at 0, end at 50, and ask MATLAB to generate 6 equally spaced points. Let's see how this works in MATLAB. Let's create a new variable called distance_linspace and use the linspace function to generate our vector. Here we start at 0, end at 50, and ask MATLAB to generate 6 equally spaced points. Notice that we get the same result again. So, if both approaches can produce the same vector, how do we decide which one to use? Well, the answer depends on what information we know and what we need to control. Let's see why this distinction can matter in an engineering context. Imagine you are part of an engineering team testing a battery for an electric vehicle. Your team wants to monitor how the battery's temperature changes during a 60-minute performance test. Let's consider these two different requirements for collecting our temperature measurements. Suppose the test protocol requires a temperature measurement every 10 minutes. In this case, what do we know? Well, we know the step size, 10 minutes. Because we need to control the interval between measurements, the colon operator is a natural choice. Let's create our time vector in MATLAB. Let's create a variable called time_column to store our measurement times. We start at 0 minutes, moving in steps of 10 and continue up to 60 minutes. These are the time points at which our team will collect temperature measurements. Now, let's consider a different requirement for the same battery test. Suppose we need to collect exactly 5 equally spaced temperature measurements during the 60-minute test, including the beginning and the end. This time, what information do we know? We know the number of measurement points we need, 5. Because we need to control the number of points rather than the interval between them, linspace is a natural choice. Let's create our time vector in MATLAB. Let's create a variable called time_linspace to store our measurement times. Using linspace, we start at 0, and at 60, and ask MATLAB to generate 5 equally spaced points. MATLAB calculates the spacing for us, giving us measurements at 0, 15, 30, 45, and 60 minutes. So, in our first scenario, we used the colon operator because we knew the measurement interval. In our second scenario, we used the linspace because we knew the number of measurements. Now that we've seen both approaches in an engineering context, let's check your understanding. Before choosing a MATLAB command, ask yourself, what does my problem require me to control? If I need a measurement every 5 seconds, which method would you choose? Well, the colon operator would be a good choice because we know the step size. What if I need exactly 10 equally spaced measurements? Well, linspace would be a good choice because we know the number of points. The key takeaway is that both methods create evenly spaced vectors. The best choice depends on your problem. Use the colon operator when you need to control the step size, and linspace when you need to control the number of points.